Alright, another draft physics video presentation. Alright, the subject will be photons, but more about structure of a photon. And some conversation about what we know about photons, what photons do, like how we detect them. Some of these things are facts they've known for a long time, but no one really talks about it. And, we have gleaned a lot of information, but no one really puts all of that information together and says, these are the facts you have to deal with if you're going to say something. So somebody has linked me to this piece of just steaming garbage as an article, a science article, claiming, what shape are photons? Holography sheds light. No, it doesn't. Okay, so just silly. This is just silly. It doesn't have anything to do with anything we know about photons. It just has to do with, well, you can make all kinds of instruments, create all kinds of images. And it just kind of looks like the whole black hole photograph kind of thing. It's just more of this science that's unproven. We don't get to see any of this evidence. We don't get to see the processing, the making of this cupcake. So it's like LIGO saying we did it. Yeah, well, it says you. And that's all. That's all there really is they say so. And you believe so. And that's sort of a problem too, is that all these magazines are selling the woo. They're all selling the religion. And there's no magazine out there saying, oh, wait a minute. There's no magazine saying, I'd say be skeptical, but even being a skeptic doesn't mean anything anymore. Skeptic means you have some other religion that you're selling, and so you're just going to propagandize in some other direction. So what we need is some sort of just fact-checking, some sort of, well, that's a nice story you just told, but here's a couple of the facts that you haven't been proven. Lights away, for example. You can't just say this stuff without any context of understanding that that's not exactly what the evidence says. Okay, the evidence is confused, can be confused. Let's say it can be confused, because I'd say yes, it's pretty substantially demonstrated that waves have nothing to do with it. But anyway, we'll get to that probably. So this came about because of a comment, so I'll just dispose of some asshole comments, and we'll get on with the video that'll actually be about something real instead of this fake crap that these bullshitters bring up. So, jack of all trades. Don't even know whether that's, this people who self-compliment themselves in their titles as if they actually are some of these things. You're more like a jerk of all trades, no doubt. So we can't start a sentence with a capital letter, too much trouble. Man, the amount of stupid is in only 10 minutes of this was just too much for me. So again, something that could be stated on every single video on the internet. You're not going to prove it. You're not going to demonstrate it. You're not going to give me any examples of it. You're just going to say this tripe. And you're saying, wow, I'm a really great human being. No, you're a piece of shit. So he's asked to provide proof, and he yawns. Yeah, well, that's really interesting. And then his example is pump pressure into a light bulb. So he doesn't think that when people talk about voltage as pressure, they're not really doing something intelligent. That's not an intelligent way to understand voltage, is pressure. Right, amperage is volume and voltage is pressure. Those are silly analogies. Those are silly synonyms even for these concepts. They have nothing to do with physics and science. No physicist or scientist of the past ever used the word pressure to describe voltage. Oh, no, exactly the opposite is true. So he provides an example that proves he's an asshole. Yeah, there, done. Okay, so now he says drawing out of view. So that's his other complaint, is that some of my drawings go out of view. Yeah, well, that's because I haven't got used to this all yet. All right, I mean, it's only been a couple of months being back using OBS. Less than that, actually. A lot less than that. Boy, the sync seems way off. But whatever. We'll hope it's okay. So, superior mind responds. So you don't understand current electricity being needed to create photons in a light bulb. Right, exactly. So we won't get any response, so we're just going to delete this whole thread. Thank you, superior mind, for asking for some sort of evidence for whatever statement people are going to make. It'd be nice if they showed some evidence, but they never do. But they don't care about the truth. Again, this is just more, it's just propagandist against propagandist. Nobody wants to take any responsibility for having to argue anything or prove anything. It's just really irritating. Alright, so just fuck off there, Jack. Alright, thanks for the videos. Greetings from Turkey. I don't know, whatever, okay. Complete silly BS. Well, this is a flat earther, so we'll just get rid of you. We're not going to even bother paying any attention. Sorry. Too silly. You're a liar. It's just that simple. You're a lying sack of shit, okay? It's an insanely silly proposition. Your conspiracy theory can make no sense to anybody rational. You're obviously in it for some other reason. You're some sort of religious kook. You know, your grandfather had a relationship with Tesla or something. I don't know. There's some kind of weird ass shit going on, fuckhead. Because your brain ain't working. No, it's working, but it's not, you know, it's corrupted by some sort of agenda. You clearly have an agenda. Ugh. So, fuck off. Alright, now this asshole. JF Hassak. Look, he sends me an email with this stupid link too. Okay, what shape are photons? Question mark. Color. Or he sends Light Cosmos magazine, web archive. So, I have to go look it up. You can't even post the fucking link, right? And it's just rubbish article. So you don't annotate your comment in any way. What are you saying? Do you believe this article means something? Do you think it has some kind of credibility? Do you think it undoes any of the arguments I've been making about what a photon is? Certainly doesn't undo any of them. It certainly is not even the same subject, frankly. These physicists aren't even paying attention to what we already know about photons. None of those facts will be anywhere in the article. Polarization won't be in the article. Nothing that we know is a fact. That the only way we see a photon is to create an electric current. There's no other way to do it. Our eyes are doing that, frankly. They're creating an electric stimuli, okay, and that's what says photon. So if you don't do whatever you have to do to create electricity, so yeah, the electricity, maybe that comes in clumps. Maybe the photon doesn't, the electricity does. So that's sort of a problem with our detectors, isn't it? That the only way we can detect a photon is that we have to cause an electric current somewhere. It's the truth, isn't it? I mean, do you have some counter argument somewhere? Is there some other device? Photodiodes, electricity. Photomultipliers, electricity. Can you give me an example of something that's doing it some other way? I don't think so. All right, so yeah. All right, so we'll move on. Yeah. So we'll draw some stuff and just start from that beginning, and then read the crappy, shitty piece of shit article that you post a link to. The absolute rubbish that you didn't call rubbish. You didn't say anything to indicate whether you believe or you don't believe. What's the point of your comment? Which I'm going to delete now that I'm going to be referencing this crap that you didn't put any warning. This is a bullshit article. You didn't say anything. Alright. So, but there needs to be a magazine that does exactly what I'm going to do, which is just going to point out that this article is just saying a bunch of things for which there's no proof. There's no evidence that any of this stuff works or does what you claim it does. So why are you claiming it when there's lots of experiments that already indicate what's going on? So why are we pretending we don't know when we do know? Alright. So I'll pause and draw. Alright, should be back. So, as I have mentioned, polarizing films provide an awful lot of information. So, the basic concept is that you can orient the film in a couple of different ways. And frankly, if you do this exact opposite way, you get zero light. There's no photon that we can create that can go through both of these filters. So it's basically screaming at us, okay? And the idea is that the filter has a real easy to understand structure. So the idea is that whatever the photon is, it definitely has some kind of shape consistent with having a dimensional shape in one direction that's quite different than its shape in the other direction. All right, it's obviously tall and not very wide. That's the concept, because it can get through this filter half the photons. So half the photons are going to go through this way, and half the photons would go through this way. And the simple argument is the ones that are tall get through. The ones that are fat, in the sense that they're tall, they're lying down, whatever you want to say. They're obviously not different. They just can come in these different ways, you know. But they definitely have this. They're always the same shape. They're always some kind of thing that has this shape to it, and that's why the filters work. And obviously, if it comes through at some angle like that, then parts of it are certainly not getting through the same way as the other parts are getting through. And that's what we sort of know. So, I mean, part of the catch here is that most physicists, because they haven't done any real looking at it or understanding of it, they haven't really thought about it, they haven't gone into the details of it, they think the photon, this polarizing film is made out of bars, solid bars, like a jail bars. And that's not what it is at all. All it is layers of plastic. All of it is transparent-ish. Okay, so it's 93.5% transparent. Okay, so there's very little real defect in it, in the sense that it should be pretty much, the idea is it's clear plastic. And all you've really done is take layers of that plastic. And so you have a layer, okay, here, and this layer causes a phase shift. That is, whatever you think a photon is, I'm going to use little dots to indicate where there's a hump. Okay, so if it was a wave, I'm going to say, no, this is what it's doing. Okay, there's nothing here, and there's a hump, and then there's nothing, and then there's a hump. Right, so the dots are where the humps are, and where these low spots are, this negative ton that you think exists, this negative wave, you think it's pushing and pulling. No, photons can just push. They can't do any pull thing. There's no other element to a photon, okay? It's just on and off. It's an on-off pattern. It's bullets. I fire a bullet, I wait a second, I fire a bullet, I wait a second, I fire a bullet. It has a wavelength, okay, that's consistent with bullet speed in 1 second, and so for photons it's light speed, and that's the distance between the bits. This is the frequency right here. Okay, so when it's 500 nanometers, it means at the speed of light, that's the distance between clumps of energy, little bits that are going to hit something and move it. And what they're going to hit is electrons. I mean, that shouldn't surprise anybody. And so so the trick is that, like 3D glasses, all the 3D glasses do is they put another layer here. Okay, so you can understand that this would cause a 1x phase shift, this would cause a 1x phase shift, and this would cause a 1x phase shift. And so all you're doing is shifting, you're phase shifting light. So you're taking a wave that's coming in where the humps are here, and you're converting it into a wave where the humps are here. And then if you do it again, they're back on phase. You can sort of get that, right? Yeah. That all you're doing is, well, do it this way. If it go, this one would be back on phase. So you can kind of get it, right? That these would line up again. If I put extra ones in here. And so all you're doing is by changing the phase, you put them back in alignment. That's all you're doing. You're putting them back in alignment, back in alignment, back in alignment. And when they're out of alignment, that can't be the same frequency. Obviously, this frequency, you know, this is a lot different than this is a frequency. Right? That's in the drawing, isn't it? Yes, close enough. All right. So, my eraser's down there. Can't really get to it. Yeah. Break the rules. Okay, so the point is the polarizing filter is telling us a lot, because we can know exactly how big these spaces are between the bars. Okay, so we have a bar that's double. This is the 2x part, this is the 1x part, blah, blah, blah. And so it's a phase shift. And so you know that a photon that's going through this way, we can figure out that at what angle does it start to get really destroyed. And you can sort of surmise, okay, that it's obviously going to get really destroyed this way in terms of breaking a lot of the bits. And very few of the bits would be broken this way. But if you thought of it as being, say, just understand that how subtle the complexities of it get. Let's say a photon was made out of 4 bits. Well, you can understand you can cut off 1, and then you can cut off 2 here, but you left more distance here than here. So it doesn't take much to knock off the second bit. So it's not going to be proportional. That is, when something's angling into it, it's not going to be like you took exactly 22% of the photon here. It's not going to work out that way, because all I have to do is put 5 of those little bits in here, and now it gets kind of confusing, right? Because then I'm left with unevenness, right? I can either take these 3, or I can take these 3, but I can never do 50% of that photon. I can never break just 50%. I'm always breaking either 60 or 40, right? So a simple little fact like that means that you can't sit there and assume that, oh, well, at this angle, I expect 25%. Well, no, at that angle, you'll get 30%. All right, because it's degrading photons quicker as it goes down. All right, I mean, it's more destructive as they start to angle down this way. It's more likely you're going to break more of the photons. So you break more here to here than you break from here to here. You break less up here than you break down here. So as you turn it, you're breaking less, and then it gets more. All right, and so that's why you have this 30% instead of a 25%. Now, they use this. This is entirely the reason why there's this thing called the Bell inequality and all this kind of crap. It's because of this fact. So regular physics says it has to be this, because they think it mechanically has to be 25%. No, it doesn't have to mechanically be 25%, and in fact it's 30% of light gets through. And it's not some big mystery, you know, that the 50% is this way, right? Because obviously you've killed that photon, you're not going to recover it. You've broken it so much that you're not going to be able to recover that photon. It's not going to be able to get to the target and create the right sequence of bang, 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 bang. See, when you take out too much of the photon, that is, you've changed the location of these bits, you've broken it too much to ever recover that frequency. But anyway, just understand that this is entirely their assumption that it has to be 25%, that's what Newtonian physics says. That's what the law says. It has to be 25% because half of 50% is 25%. And the simple truth is that's not the rule, though. The rule is that it gradually gets more destructive. The more off the perfectly vertical the photon is, the more it comes in at the wrong angle. So when it comes in at this angle, it's a lot more likely to be destroyed. And at this angle, it's a lot less likely to be destroyed. And so there's a difference. And that counts for this difference. Now, they don't account for that. So they say, oh, the Bell inequality has been violated. It didn't come out to be 25%, therefore the particles must be wooey and they must be entangled. So that's the truth of it. This is the history of entanglement right here. A misunderstanding of what polarizing film does. All right. So the purpose of this video, though, is not to debunk entanglement. It's to point out that we have learned from polarizing film a lot about the shape of a photon, okay, because of those filters. So we know the filter does, it's got a length to it, and that means that we can tell how much off a photon can be, okay, how much it can be coming in at a strange angle and still get through the filter. All right, so this is stuff we do know, and that tells us how long this photon is. All right, and the truth is, though, we sort of already know how long it is because of antenna polarization, because we know that this photon is the same as the radio photon, is the same as all the other photons. So all the other energy created in the same manner, this little bits of electron pushing energy at a frequency, we know it's all behaving fundamentally based on the same rules. And that the truth is that a material that you're making photons in has to push electricity to do it, to make a photon. And that it has to stimulate this creation of a photon as a timed event. That is, a piece of it goes out, one clump of the wave. And then at a timed interval, as the electricity travels through the atoms, another atom is stimulated to produce one of these bits, these extra bits, a reflection, you could argue. And it's a timed event, and the timing is all based on the speed of the electricity, which is almost the speed of light. So the electricity is traveling through the atoms, the pushing of the electrons in the atoms, the imbalancing of the atoms, however you want to describe it. The atoms trigger, okay, and they all shoot an electron in a direction. Pushing the electron means you've pushed a piece of the force, and that's the creation of the photon. So what we know, all right, what we can know, what we can observe, what can be understood reasonably as a reasonable explanation for what's actually taking place, is that the polarization is based on the fact that the bits are moving in the speed of light in this direction. We created them at the speed of light in this direction. And so there's a consistency between the wavelength, okay, between the clumps and the speed of light, which means the distance of them. So if I was to draw what a photon is, and I'll try to make it acceptable to you wave nutters, I'll try to make the acceptable analogy. Why does wave theory work? In a lot of ways, you can use waves to describe what photons do. Well, because waves are clumpy, okay? It's just a fact. So it works, but I'm just telling you it's not right. It's not the correct understanding, because the photon isn't gradually turning on and then going opposite. There's no pull to a photon. Photon's never been shown to ever pull a piece of matter anywhere. No one's ever shined light on something and made it move towards them. It doesn't happen, okay? There's no pull element, whatever that would be anyway. There's no pull element in the entire universe, frankly. There's just a lack of push. All right. I mean, they're really, well, whatever. I was just going to bring up yin yang. It's just saying, well, they sort of got the right idea. Okay, all you could do is push or not push. That's what yin yang is. But anyway, what was I wanting to get to? Okay, so a photon travels through space. All right, and what the polarizing film is basically saying is that these elements are all moving parallel, because we know the photon can go billion of light years, and this distance does not change. Okay, it's polarization distance. And the polarization distance, again, is just known from the filters. We know from the polarizing filters that it has to be this kind of size because we know how far apart those bars are. And by knowing how far apart they are, we can know why we can block all of the photons with the filter, and how much it takes to make one break. But the other part is, I guess we could detect some of this on the receiving end. So the point is that whatever you want to think it is, the fact is this polarization is maybe 1,000, okay, for the average bit of light, the average bit of visible light. This is 1,000 atoms worth, okay. So if I was to, if I was just to give it in distance, it's 1,000 atoms of polarization. Okay, and it's 1,000 atoms worth of distance between the bits. So you have to understand a photon is kind of a large thing, and it takes time for it to be absorbed. It isn't absorbed like, it hits a surface, bang, photon. That doesn't happen. Okay, and it also doesn't happen that there's ever this, circumstance where, they describe atomic events and they say, you have an atom. I mean, they can know this is wrong, and you have these energy levels, right? You have the nucleus here, and the electron pops, from one level to another, and by popping, flying from one energy level to another, and presumably at a big speed, that's the quantum part, because it's so fast, they have no way of measuring it, that it's instantaneous, they're saying. It's not instantaneous, and you know that. But anyway, it moves, and by moving to a new position, that's when it creates what they call a photon, and they'll draw it as a squiggly line and say that's a photon. You can sort of surmise that it can't be creating something that has a polarization of thousands of atoms, and it seems pretty unlikely that it's going to be in a position to sit there and create, that it would create a clump, of stuff, a reflection, whatever you want to call it, clumps of stuff. You could create 3 or 4 of these little things together coming out. See, as it moves out, it takes everything that's coming towards it and reflects it. So if you thought of it as something reflecting, that is, it's moving towards you, and let's just assume there's cosmic background radiation. There's radiation in the universe coming towards it all the time. And when it moves really fast into that radiation, it means it would collect all of the radiation that's moving the speed of light between it and you, and it would essentially clump it. It would say, like, if there was a bit here and a bit here and a bit here, well, they all sort of have to be lined up with the electron. Erase this part. So here's an electron. It's going to move from here to here very fast, okay? So you have to understand that while it's doing that, there's little bits of energy here, this photon stuff, okay? There could be one coming in, so just imagine this on top of that, you know what I mean? It's heading for it, and there could be one here, and there could be one here. You can understand that if I move this fast enough, what I'll do is reflect this one, and then I'll reflect this one at the same time as this one. This one's going to go here by the time I get here. That means I'm going to reflect this one from the same location, so now there's going to be 2. And then when I reflect this one, these 2 will also be moving in that direction. So when I reflect this one, I'm going to have all 3 of them. Now all 3 of them are going to be exactly in the same plane. Now all 3 of those clumps will be now returning, being reflected. So when I move really fast towards you, what I do is I consolidate all the energy between me and you, and I push all of it to you at one moment in time. I line them all up. And so that's what the electron can do, is take whatever diameter the electron is, of course, and it will push whatever amount of energy is in that, whatever amount of energy is in this space between the distance that it's going to move. It will take all of that energy and now make it into one clump, okay? And clump it all together. It's all going to be in a group now. Okay, it's going to be a school of fish, not random fish anymore. Randomly spaced fish. So that's what an electron can do, but an electron can't create, okay, a single electron clearly can't create a polarization that's thousands of atoms of difference, right? It can't do that. And what it just did was it just made a clump. It didn't create a whole bunch of waves. It created one hump. So clearly what has to take place is this has to happen more than once. You can't have a photon if just one electron jumps. That's not going to create a photon. You have to have another electron jump over here, and you have to have another electron jump over here. All right, and they have to jump, okay, within the rational spacing of how electricity moves, so you can sort of understand that it's really kind of a pushing argument, right? Now, you know, if I was coming at an angle at something, and I had these waves, that is, these different clumps coming at different times, you might be able to understand that the first one would push here, and then the second one would show up and push it again, and the third one would come up and show it and push it again. And that's a more rational understanding of the fact that it has to be a sequence of events for there to be, you know, a photon. So a photon is something that flies through space, not as a thing, okay, not as one thing, but as an event cause, event 1, event 2, event 3, event 4. They're events. The photon takes time to produce. It takes whatever, 500 nanometers here, so that's a certain amount of time, 500 nanometers here, a certain amount of time, 500 nanometers here, it's a certain amount of time at the speed of light. You have to add up all those times, and that's how long it takes just to make the photon. And the same thing is going to happen on the receiving end. It's going to take time to receive the photon. It doesn't just happen. It isn't just one little clump there, photon, done. No, it's an event that takes time. And it has to be more than one of these things has to happen. And it's happening over a rather large surface. So the same truth is true about this polarization, is that the only surface that can absorb a photon has to be at least 1,000 atoms, okay, of surface. If you have less than 1,000 atoms of surface, you're not going to reflect a photon, that's for sure. You're not going to be able to recognize it by creating electricity. So part of the trick to making something very dark, okay, is to actually make it very spiky. Okay, make the surface very spiky, you can make it very dark. And part of the reason why that would work, is you can sort of surmise, is that the bits are going to end up hitting all kinds of different locations that are way too far away from each other to create an electric current. So the photon is going to be consumed as little individual events that aren't going to have their timing cycle. They aren't going to be able to push, you know, the same atoms. They're not going to be at all coherent, and that's why that's so dark. It's because it can't possibly return what it received, you know, mechanically. It's not enough atoms in a row. And so the other thing is that crystals are what metals are made out of, and that these crystals, you know, you could just say some sort of, you know, we'll make it a simple crystal, a square one, okay, that there's just, this is a group of atoms that have an arrangement, and that's what creates electricity. That's what converts. Photons hit the crystal, and the crystal creates the electricity, which means that somehow it's converted on the edges. So where the edges of the crystals are, so where two crystals are meeting each other, you might understand that this is a funky edge. And what's probably happening, I would argue, is that yes, you send the pressure into this crystal, it pushes electrons on that edge, and that's what's called electricity. The electricity moves on this edge, then this edge, then this edge, then this edge, then this edge, and this edge. The imbalance is transferred through all the crystals to the outside of the outside world, and that's part of the function. And then transmission, you know, transparent objects would also be using this mechanism to transfer the photonic energy to the opposite side and release it again. But that's a little more complicated than I want to get to. All right, so before we go to the article, let's understand what I think can say with some confidence. We know that we can't make a photon that goes through both polarizing film. So we know that we don't have any photons that aren't polarized. Okay, and we know that the polarization is large. And it's sort of a demand of the system. Yeah, you have to, you really just don't get the choice. Now the interesting thing is the photo detector, so I guess I'll go with that, because that one, you don't know how many electrons you have to actually, all you have to do is get an electron to fly across a gap, to sit there and say photon. So you're creating a surface, that has a bunch of electrons on it, okay, and they're all dying, to jump the gap. So there's no, less electrons here, right? So you've got high pressure electrons here, low pressure electrons over here. Now the consequence of that, it's also creating a field, and the field would be, the argument is that you're creating energy, okay, that's actually moving in this direction, and that's part of this. And so all you need to do is barely hit one of these electrons and it'll get into the river and flow with the energy. The energy will push it across. The electron doesn't push it across. The energy in the field pushes it across. And the energy in the field is created by the fact that there's this pressure argument. Lots of reflections off this side, and they're all ending on this side. So there ends up being a flow of energy in one direction, because this side reflects nothing, because it has less electron, it reflects less. So there isn't any energy going this way, but there's lots of energy going this way. And by energy, I mean the stuff that reflects off of an electron. And so the idea is you want to hit one of these electrons, force it across, and once it goes across, it'll create 3 other electrons or 4, and you have a cascade of electrons, and that says, okay, we saw a photon. So it's a way of creating. So the question would be is, can you move one of those with just one piece of a photon? No. And I would argue that no, you're still, if you do that, you'll get, the thing will just click, 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 click all the time. It'll just go off all the time, because there are so many of these little individual bits of energy in the universe that your photo detector would just be useless, because you couldn't tell the real ones from all the energy hitting it all the time. Gravity, for example. All of the forces would be. So the key is that the frequency still has to be important. And there has to be, you hit it more than once. You cause a cascade that causes it to release. So you have to hit it and then hit it again when you moved it from here to here, and then you hit it again, and that's when you have enough speed to knock it out. But you still have to hit it more than once. You still have to add energy. So the point would be is that what really knocks the electron loose is that not you hit it once, gave it momentum, now you hit it again and gave it extra momentum. So you're increasing its speed, and by increasing its speed, you're going to increase the likelihood that it jumps into the river and flows across the gap. But you have to get enough speed, and that's why higher frequency light is more effective, because it's more likely to add energy to an electron, get it up to speed. It has more chance. Than the longer you delay between your hits, the less likely it is you're going to hit the thing. It's be the simple rule. Alright, so what do we know? We know about photons is we know when they're traveling through space, all of their elements have to be parallel, because they don't fall apart, they don't get smaller, they don't get bigger, they're in parallel. They were created by some event that creates elements. The photon clearly has elements, that the elements are what creates the wavelength. Without the elements, there's no indication of a wavelength, so you got to have the elements. And it's it definitely has a shape. I would say like an envelope. You could just draw these circles, take the envelope, and understand that all I have to do, if I take an envelope, I'll get an idea. I just draw, I draw an envelope, right? I just put a photon there, a piece of a photon in those locations, and I've basically described it. It's very thin, but it's very tall. And That's what's flying through space. And so this garbage article isn't dealing with any of these facts of a photon. Facts that are fairly easy to discern and understand. Pretty plainly good facts. They're pretty good facts. All right. So, horrible article. Called Physicists Create a Hologram of a Single Light Particle. Yeah, so there you get it. What's the shape of photons? Holography sheds light. No, it doesn't. All right. I can barely read this. Imagine a shaft of yellow sunlight beaming through a window. Quantum physics tells us the beam is made of zillions of tiny particles of light. So again, it's tiny particles, but it's not light unless there's a bunch of them. You know, there's more than one. So the tiny particles really do have to be called something else. And I'd argue calling them force bits makes perfect sense, because now you can use the same tiny particles to create gravity and to create charge. So it simplifies everything. But again, the word photon is so broken in this environment that almost nobody can use it anymore, because what are you talking about? We know the photon has to have the frequency. We know the photon has to have the polarization. So we know the photon has to be a composite. Even a wave theory, you know you have to have more than one wave, or you can't tell the frequency of the waves, can you? You got to have more than one. All right. Called photon, streaming through the air. But what does an individual photon look like? So we know an individual photon is what we measure. We measure photons. That is, we measure the fact that its energy, doesn't matter where it came from, hits a surface in a certain sequence. So it gets hit, bang, 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 in the right order. And it doesn't matter where it came from, what was happening. No, that's all it needs is the signature. Bullet, 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 bullet. All it needs is the arrival of energy at a sequence of time. That's a photon. Okay, but the bits inside of the thing, the bullets, aren't a photon. So again, it's a pattern. The pattern is a photon. I fire the bullets in just random order. I don't have a photon. So confusing bullets, confusing waves with a continuous flow of blob of waves, you know, is a real that's a real problem for having any kind of rational conversation. Streaming through the air, but what does an individual photon look like? Well, I'm arguing clearly we already know that. It looks like an envelope. Okay, it's very thin, kind of tall, and it has a length. Okay. Does it have a shape? Are these questions even meaningful? Well, they would be meaningful if you were going to sit there and compile evidence for what we do know about photons, you know, and how we do measure them and how we do collect them, and what limitation does the bucket we're putting them in? Do we say a peach is a bucket of peaches, or is a peach in a tree? Okay. Now, Polish physicists, so this is not a good sign, right? You know, have created the first ever hologram of a single light particle. So isn't this a bold claim? Kind of an extraordinary claim. Will we get extraordinary evidence? I'm sure we won't. Okay, the feat achieved by observing the interference of two intersecting light beams. So we know, frankly, that you can't intersect two light beams. Can't be done. And I would argue, directly. And the only way we can do it is by scattering light off of surfaces. Yeah, right. You know, frankly, it's what it is. That's the truth. There's no photon interfered with another photon. No, there's just, you can break photons and then you can remake them because they're a pattern. You can have a pattern going in, you can mess up the pattern, and then you can collect some of the pattern back. Truth. is an important insight into the fundamental quantum nature of light. So again, this is all crap you have to believe. We have to believe in the Holy Ghost and their Jeebus, and then all these stories are going to be told about what the Holy Ghost and Jeebus did. And it's just, they're just stories. Okay, the result could also be important for technologies that require an understanding of the shape of a single photon. Well, again, you're going to get that understanding by recognizing what a polarizing film is, because that's telling you an awful lot. Such as quantum communication and quantum computers. So again, quantum computers are never going to be a quantum computer. The whole idea is silly. So computers that don't have to work very hard. I mean, yeah, right. It doesn't have to do any calculations. You can do all of them at once. No, it can't. Okay, we performed a relatively simple experiment to measure how and view something incredibly difficult to observe, the shape of waveforms of a single photon. So again, says them in gibberish language. Okay, says whatever, Radoslaw Chapanopatskowitz, a physicist at the University of Warsaw, that lead author of the new paper published in whatever this is, Nature's Photonics. So who's peer reviewing? Is it peer reviewed? I don't know. Doesn't really matter, because we don't know what the agenda of any of these magazines are, what they're selling, what they're paying for, what they're financing. I mean, it's just, there's nothing. So you might as well just tell me a bunch of Muslims looked it over and they approved it. For hundreds of years, physicists have been working to figure out what light is made of. Clearly doesn't matter. We know it's made of something that carries momentum, so we can know that for sure. And I would argue that it's clearly, we can sort of understand that it's a frequency, so whatever it is, it's clumps of it at a frequency. And the idea that it pushes and pulls is just plain silly. Okay. The debate seems to be settled by Scottish physicist James Clerk Maxwell's description of light as a wave of electromagnetism. So again, Maxwell back in whatever 17 something or other. So we know for sure because of Maxwell, or 18 something or other. No. I'm just saying this idea that it's a wave is obviously a notion. It wasn't some kind of proven fact of anything. And again, I can describe a frequency. So, if all they had to do is change this rhetoric a little bit, a frequency of electromagnetism, a frequency of magnetism, even. And they wouldn't do that, even though that's what it has every appearance of being. All right, but things got a bit more complicated at the turn of the 20th century when German physicist Max Planck, then fellow countryman Albert Einstein, showed light to be made of tiny individual packets called photons. So again, the packet idea, just again, why would you call a bit a packet? So the idea is still they're talking about the photon itself as a packet, right? A packet of what? Well, a packet of frequency. A frequency of what? Frequency of momentum. So, I mean, it's such broken language. And again, as much as I want to just say, oh, Einstein was so right, obviously the logic is a little flawed, because the only way we can detect the objects is to use a clump detector. The detector has to have a clump. That's what it tells you. It's a clump of energy. All right, that it produces. A clump of electricity is the bottom line. And it's basically telling you it only comes in clumps because that's what my detector detects. The peaches go into the bucket. When the bucket weighs a certain amount, then it goes down the conveyor belt, right? So what am I detecting? Am I detecting peaches, or am I detecting buckets that are full? Anyway, in the 1920s, Australian physicist Erwin Schrödinger elaborated on these ideas with his equation for the quantum wave function. So again, it's not a wave function, it's a probability function, and it really just doesn't have anything to do with the mechanics of a photon. So again, that's just nonsense. This has more to do with the probability of scatter. So again, simple analogies can be drawn, and you could just say, well, what's causing the probability? The electron. I mean, it's so easy to just say, well, of course, every time you hit an electron, the electron could be in a different position, and it's going to move out of that position in a different direction. So obviously, I would end up with some sort of probability curve for when I hit the average electron, what position the electron was in when I hit it. Whether you hit a car, you're just going to hit a car. You can hit it on the side, you can hit it front end, you can hit it back end. There's lots of different ways you could hit the car, and that you're going to have a different direction that the car is going to move. All right. A different amount of your energy will be converted into motion. In the 1920s, Australian physicists, we already did that, function to describe what a wave looks like. So that's just so horrible. It has nothing to do with what the wave looks like. So again, it's just silly to sit there and say the consequence of the event is going to show you what the cause look like. It just isn't. Which is proved incredibly powerful in predicting the results of experiments with photons. So that's just absolute nonsense. This is like saying the equation tells us that there's so many faces on a dice, and I'm going to roll them, and somehow I need Schrodinger's equation to tell me, oh yeah, there's only 6 faces and they only can do this many things. Well, I already know that. I can just look at them. So I don't need no Schrodinger equation to figure this out. But despite the success of Schrodinger's theory, physicists still debate what the wave function really means. So here they're saying that the success just makes it overwhelming, and everybody should accept that the wave function is real, and that proves that the universe is random, and that there's a random God who's just fucking with us. For what purpose? For what use? He's randomly fucking with us. I mean, it's such a disgusting. There's a God, but he's brainless, and he just steps on things. Oh, what a great idea. I don't know how I got through life without that wonderful understanding of the reality. Oh, great. There's a tormented 1-year-old stomping around the universe. Oh, how cool is that? Oh, shit. Now physicists, so they haven't gotten to anything yet, right? I've been reading, and they haven't even gotten close to this evidence. Now physicists at the University of Warsaw measured for the first time, so again, this bold claim, the shape described by Schrodinger's equation in the real experiment. So a real what experiment? A real childishly insane experiment? All right, anyway, photons traveling as waves can be in step. Oh, isn't that interesting? Yes, they have to be, or you can't see them. The frequency has to be consistent, right? As soon as I change the distance between any of the composite elements of a photon, I have broken the photon. The photon doesn't work anymore because the process is all about timing. It's all about pushing at just the right time to add energy to the sequence of events. That's how you create the electric current, is to have a sequence of events that push. All right. Called having the same phase. If they interact, they produce a bright signal. If they are out of phase, they cancel each other out. So none of this canceling out thing or bright signal thing. The bright signal just has to do with the fact that as soon as you create more sources of parts, right? So if I have points that light is scattering off of, as soon as I add another source, I quadruple the likelihood of recombining photons, making them again. So adding sources, okay, multiplies how many parts are available, and therefore increases the likelihood that I've put pieces back in the right order. And that's all. There's no light plus light equals dark kind of crap. Okay, they interact, they produce a bright signal. if they are out of phase, they cancel each other out. So there's no canceling out of energy and momentum. You can't destroy it. You can't cancel it out. It's just nonsense. No evidence of it anyway. It's like sound waves. Well, it's not like sound waves. There's no medium. There's no push and pull. It has nothing to do with sound waves. Okay. From two speakers producing loud and quiet patches in a room. Right. Those are, that is momentum traveling through a medium. There's no evidence that there's a medium for photons, and there's certainly no evidence that photons have any pull capacity. Okay, the image, which is called the hologram because it holds information on both the photon and the shape and the phase. Well, it's just silly. So they're saying they've created some sort of three-dimensional image of the photon or some kind. I don't know what they're saying, but it's crap. Okay, and clearly those images are crap, right? Nowhere in that image do we see any dimensions. Nowhere in the image does it explain polarization film. How does that thing get through the polarizer? How does that round thing get through bars, jail bars? How does it have anything to do with jail bars? Oh, that's right, it doesn't have anything to do with it. Was created by flying two light beams at a beam splitter. So we know that the word beam splitter, anybody who's watched any of my videos, we already know. Come on, you can't just say the word beam splitter. It just doesn't mean anything. You have to concede that a beam splitter is not doing what it says it's doing. It's not benignly creating two equal beams of light. The two beams of light are fundamentally different. One went through little tiny slits, one didn't. We know that has a consequence. All right. Made of calcite crystal at the same time. So they put it through a crystal of some sort of stuff and called that a beam splitter. Okay, the beam splitter acts a bit like a traffic intersection. So we're just, this is all just so baby talk. We know that's not what it's doing. So why are you analogizing it to something that's benign? Traffic stops don't flip trucks upside down. They don't do all kinds of things. They don't do what an actual beam splitter is actually doing to photons, which is breaking the fuck out of some of them. Where each photon can either pass straight through or make a turn. The Polish team experiment hinged on the measuring which path each photon took. So more rubbish about how they can do any of that. Which depends on the shape of their wave functions. So, just more gobbledygook. So what do we have as an experiment? Oh, lots of little funky things, right? Look, we're going to put it through a big block of this stuff, and then we'll put it through this roundy thing, and then we'll put it through this beam splitter, and we're going to say, yes, we took an accurate picture of a photon. Hilarious. Okay. Scheme of the experimental setup for measuring holograms of single photons. So again, even the concept of a single photon is just, extraordinary. For anybody to say they have any way that they captured a single photon somewhere is so unrealistic. For the photon on its own, each pass is equally probable. So there's no such thing as probable. There's just inevitable. So again, this is all, we all have to accept some notion that the photon doesn't know where it is and it can't know where it's going and it's blah, 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 blah. It's just a bunch of crap. But when two photons approach the intersection, they interact and these odds change. Says them, right? We won't really have any evidence of that. The team realized that if they know the wave function of one of the photons, isn't that so cute? Oh, they know what dress it's wearing. They could figure out the shape of the second one from the positions of the flashes appearing on the detector. The flashes of what? Photons? So they're basically saying, look, we imaged photons with photons. Everybody knows you can't do that, right? You can't shoot photons at photons and see the photons. It's like shooting Volkswagens at Volkswagens to see the Volkswagen. Not going to work. It is a little like firing two bullets to glance off each other in mid-air and using the deflected trajectories to figure out the shape of each projectile. So again, it doesn't make any sense. You can't do that. So why even analogize it to something you can't do? Each run of the experiment produced 2 flashes on a detector, one for each photon. After more than 2,000 repetitions, a pattern of flashes built up, and the team were able to reconstruct the shape of the unknown photon's wave function. So this is something like the experiment where they took the picture of light traveling through a plastic bottle, and it's really not a picture of light traveling, a photon traveling through a bottle. It was just a time lapse. So all they did was watch a beam of light travel through a bottle, and they took a picture at different intervals. And the intervals are much slower than the actual thing, so it's different intervals of different photons going through the bottle. And that's all it was. So it wasn't one photon being watched. It was just a picture of what photons do when they travel sequentially through the bottle, what it looks like at each point, how much light is being reflected out of the bottle, how many of the photons are actually hitting the plastic and bouncing towards the camera. So it's not really showing you photons that successfully got through the bottle, it's showing you the ones that didn't get through the bottle. Anyway, each run of the experiment produced 2, okay, we did that, right? Yeah. The resulting image, okay, so it's an image made out of 2,000 images. Looks a bit like Maltese cross, just like the wave function predicted from Schrodinger's equation. So this is just absolute nonsense that there's any Schrodinger equation that predicted that cross. So that's just horseshit. Clearly what's predicted is Newton's rings. But anyway, in the arms of the cross are the photons. In the arms of the cross where the photons were in step, that means in phase, I guess, the image is bright, and where they weren't, we see darkness. So again, it's just a composite image of, you could overlay, if you overlaid different path length of photon rings, right? So you've spread different photons from different locations. They each actually from that location, they'll all create a ringed pattern if you did it 1,000 times. So from each one you're just overlapping the ring patterns. That's all you're doing. The experiment brings us a step closer to understanding what the wave function really is. So no, please, it's just such garbage. Says Michael Jacolia, who co-authored the work. And it could be a new tool for studying the interaction between 2 photons. So again, it's not the interaction between 2 photons. They conceded it's 2,000 repetitions. So, just always horseshit. So they threw 2 beams of light at each other 20,000 times and are showing us a composite image of what you get in terms of the overlaying of their diffraction patterns. Okay, and they're saying that's a picture of a single photon. I'm just saying right there, obvious shenanigans, bullshit. They're not describing this accurately at all. This is all just hype on which technologies such as quantum communication and some versions of quantum computing rely. So they think that this silly pile of nothing experiment is going to somehow have some utility. Well, I predict it will have none, ever. The researchers also hope to recreate wave functions of more complex quantum objects such as atoms. Well, atoms aren't complex at all, and they don't have all these quantum functions, and that's all a pile of crap. So it's likely that real applications of quantum holography won't appear for a few decades yet. Yeah, a few hundred or a few million or a few billion, says some berserknik, who also is part of the team. Yeah, But if there was one thing we can be sure of, it's that they will be surprising. Oh, it's all about the surprises. So this is the douchebag Australian nutter, who's the truther guard. He's the one protecting us. Yes, I'll scrutinize this physics and tell you what's real. Yeah, not even close, fella. All right, so again, let's look at this horse shit. Yeah. So obviously you can sort of get the idea that yes, of course, if the rings are different sizes, they're going to match in different locations. Not complicated at all. That you're going to get a pattern. You can mess up the pattern by putting two different frequencies, two different, phases on top of each other. So, yeah, it doesn't mean a thing isn't real, doesn't say anything about what a photon is, and doesn't get to the reality that photons can have an understandable shape. And that shape is an envelope with little dots in it. Yeah, little dots on it. It's a bunch of parallel flying pieces of momentum. And it has a length. That means it takes time to make a photon. And it takes time to receive a photon. It takes time. Frequency. Time. All right. So it's made of pieces. And it doesn't have any negative components. It just has positive components of momentum. It's completely binary. It's on. There's bit of momentum, then there's nothing. So look, it's just like me moving. I move in the cosmic background radiation. Well, right now there's light cast on me. And you can know that if I actually could move really fast, that I actually would be forcing more photons to hit me. And they would be more photons going into the camera. And you can know that if I go back really fast, that there's less photons that can possibly hit me, less they can get to the camera. Now, I'm also becoming optically smaller. That is, you are going to be able to receive a lot less photons because of the angle changes. You're getting less of the cone by the inverse square law. But if we took away the inverse square law and just pretended we didn't have that optical problem, you can just get the idea that if I'm moving away, nothing can bounce off of me as I'm moving away from its momentum. And that simple explanation explains what takes place here. There's no negative photon. There's no negative component. There's either you push or you don't push. You push, you don't push. You push, you don't push. That's the on-off. Alright. As stated, all I can do is reason with you people. You can't, it's nothing, I can't make you reasonable. So, there, of course, will be no one will make any rational contribution to this conversation. So, unfortunately, it has to be one-sided, I guess, until the future, when people just say, oh, yeah, it's too bad nobody was part of the conversation. Nobody even had the conversation. They just ignored that shit. And, we just sat around, sticking our fingers in our own butts, doing this stupid, look, I made a cross out of a, hologrammy crystal. Isn't it cool? It's a photon. That's what I called it. Yeah. The interesting thing, I have been playing with the different, the experiment you can do with your little fingers. You can put your fingers very close together and get them to make little lines and stuff. And I found that this is, I was taking some pictures and that it's not the same thing happening at all. It really has to do with focal length, because to actually see the little lines, you have to have your fingers way out of focus. Yeah, and because when you have them in focus, you use a camera and you have your fingers in focus, no lines. But if I put your fingers out of focus, I get the little lines. And so it's an image aberration. It's not doing the slit experiment thing. Anyway, I just thought that was interesting. So there's lots of that to work with too, optically, what's going on. But anyway, till the next time and such and so forth and whatnot. But I mean, we have lots of evidence of, that tells us what photons are. And everybody's just nobody's forcing everybody else to have a conversation within the same place where we have the same piles of evidence lined up. We have the same. It's like the trial. Every day they do the trial, they put different evidence on the table. And it's like, no, the evidence should always be on the table. And if people want to refute some piece of the evidence and say that's not what it really indicates, or that's not this, or that's not that, then that should be cited, and we should all be in agreement that we want to get the evidence understood well and not overstate what we see. Like saying that the Planck constant, the clumpiness of light, may be the fact that our detectors are clumpy. And that's a good argument, just to point out that, yeah, it looks like clumps, but is it really clumps? Does that prove clumps? I'm saying it's clumps, but I'm just saying, is that proof a good proof? Or do we need more to demonstrate it's clumps? I'd say the obvious fact is it comes at a frequency which is obviously clumpy. I mean, it's really just an argument about waves or bullets. Can bullets explain it? Yes, bullets have a frequency. Bullets can have a frequency. Bullets carry momentum. Bullets have all the pieces we need to explain what's happening. And all we have to do is be fair to bullets. Can I create a surface that causes bullets to diffract, to go scatter off of a surface? Certainly I could create a surface that does that. Could I understand that at different locations I'll put the bullets back in a pattern? They were fired one every second. They go into the slits. The slits are going to, in a sense, create different path lengths. If the path lengths are a whole frequency, a whole amount of time change, then obviously the pattern can be retained. And that's all you're collecting, is the pattern. So bullets work. So let's quit implying that there's some evidence that proves bullets don't work. There is no such evidence.